So we're going to be looking at how to determine if values make an inequality true. And we've looked at something similar before. We looked in an earlier stop about how to determine if values make an equation true. And it's similar, but not exactly the same. So we want to understand first the difference between an equation and an inequality. And basically, an inequality is a mathematical sentence that compares quantities using these symbols: less than, greater than, less than or equal to, and greater than or equal to. So when you look at the word inequality, okay, you can kind of see it's unequal, not equal, right? An equation always has an equal sign. So equations, you're going to be looking for the equal sign. Inequalities, you're going to be looking at something that's not equal, okay? And so if it's not equal, then you can say it's less than, greater than. Or it could be more than one thing. It could be less than or equal to, greater than or equal to. All right, so to determine if a value makes an inequality true, you're going to start by replacing the variable with the given value. So you're going to be given a set of values. You're just going to plug it into the inequality and then determine if the values make the sentence true. Now, in an equation, the equation was true if both sides were the same, because we were looking at for things that were equal to each other. And in equality, that's not necessarily going to be the case, because you might have something, you might be using the symbol less than, so that you might be wanting something that's like 2 less than 3. That would be a true sentence, but then like 3 less than 2, that would not be a true sentence. All right, so we want to make sure that the values we're given give us a true statement. And then the other difference you're going to see is that inequalities may have many solutions. So equations typically have one, but inequalities will most likely have multiple solutions. All right, so let's look at our example. Sorry, I know that's shaking quite a bit. It says determine if 3, 4, and or 5 are solutions to the inequality. Again, it's going to be important to check all of the values, because there can be many. All right, so if I replace C with 3, then what I get is 3 plus 3 greater than 7. So if I go ahead and add that, 3 plus 3 is 6. Is 6 greater than 7? No, that is not true. 3 is not a solution. All right, what about 4? If I replace C with 4, is 4 plus 3 greater than 7? Well, if I add 4 plus 3, I get 7. Okay, 7 is equal to 7, but I'm not looking for equal, I'm looking for greater than. So this is not a true statement either, so it's not 4. All right, and then the last one is 5. If I replace C with 5, 5 plus 3 is going to be 8. Is 8 greater than 7? And yes, 8 is greater than 7, so this is true. 5 works as a solution. All right, and then just make sure you know the names of these symbols, because that's going to help you determine if they're true or not. So this is greater than when it's facing this direction. What helps me remember is that the wider part, the mouth part, right? If it starts out this way, right, the bigger part, you're going to the smaller part. So greater than gets smaller. Okay, and then if it's turned the other way, you're starting with the smaller part and getting bigger, so less than. I don't know. That's just how I remember it. Hopefully you have a trick to help you remember. All right, determine if 15, 21, and or 24 are solutions to the inequality 5 minus m divided by 3 less than or equal to negative 2. All right, so we're going to place m with each of these values. I have 5 minus 15 over 3 less than or equal to negative 2. All right, this just means division here, so I'm going to start with that. 5 minus 15 divided by 3 is 5. Less than or equal to negative 2. All right, 5 minus 5 is 0. 0 is less than or equal to negative 2. All right, so for less than or equal to, 2 things could make the statement true. Is 0 less than negative 2? Okay, so if I think of a number line, here's 0, here's negative 2. Okay, as I go this way, the numbers are getting smaller, right? So which one's smaller, negative 2 or 0? Well, negative 2 is. So is 0 less than negative 2 true? No, that's not true. Okay, but this also has the equal to sign, so I need to check also to see if 0 is equal to negative 2. Is that true? No. All right, since neither one of these are true, it's not less than and it's not equal to, then this is false. Okay, this is no good. It's not 15. All right, try 21. 5 minus, I'm replacing m with 21 over 3, less than or equal to negative 2. All right, so start with division. I have 5 minus 21 divided by 3 is 7, less than or equal to negative 2. So I can't subtract 7 from 5. I'm going to rewrite this as 5 plus negative 7. Keep, change. What's 5 plus negative 7? Negative 2, less than or equal to negative 2. All right, so is this a true statement? Well, is negative 2 less than negative 2? Well, they're not. It's not less than, but that's not the only thing that makes this true. Is negative 2 equal to negative 2? Yes. Okay, so either one of these makes this true. This is a true statement, so 21 is a solution. All right, how about 24? 5 minus 24 over 3, less than or equal to negative 2. So I'm going to start by dividing. 24 divided by 3 is 8, less than or equal to negative 2. I can't subtract 5 minus 8. I'm going to rewrite that as 5 plus negative 8. Then 5 plus negative 8 is negative 3, less than or equal to negative 2. Is negative 3 less than or equal to negative 2? All right, well, if I look back at my number line, where is negative 3? It's over here. So is negative 3 less than negative 2? Yes, it's further to the left, so it is less than. Okay, is it equal to? No, but it doesn't have to be both. It only has to be one of them. This is also true. That means 24 is also a solution to this inequality. All right, look at number 3. Determine if negative 4, negative 5, and negative 6 are solutions to the inequality. All right, so I'm going to replace x with negative 4. Since this has a 2 in front of it, that tells me I'm going to be multiplying. So 7 minus 2 times negative 4 less than or equal to 15. All right, so if I multiply, and then one way to do this when you're having to multiply, and this is subtraction here, I can go ahead and make this plus a negative 2. So keep, change, opposite plus a negative 2 like that. And that way when I multiply, I'm going to get rid of that. A negative times a negative is going to be positive. That's just going to make it simpler. So negative 2 times negative 4 is positive 8. So this becomes 7 plus 8, less than or equal to 15. And if I go ahead and add those, right, I'm looking for either one of these. Is 15 less than 15? No. Is 15 equal to 15? Yes. All right, so then this one's okay. So negative 4 works. Okay, try it with negative 5. I have 7 minus 2 times negative 5. Right, and again, I'm going to rewrite this as plus a negative 2. Keep, change, opposite. Negative 2 times negative 5 is positive 10. Is that less than or equal to 15? Well, 7 plus 10 is 17. 17 less than 15? Nope. Is 17 equal to 15? Nope. So this is not true. Negative 5 is not a solution. What about negative 6? 7 minus 2 times negative 6. Okay, so again, I'm going to keep, change, opposite, or copy, change, opposite. 7 plus a negative 2 is negative 6. A negative 2 times a negative 6 is a positive 12. 7 plus 12 is 19. Is 19 less than or equal to 15? Well, it's not less than, right? Because I know that 19 is bigger than 15. Is it equal to 15? Nope. Right, so this is also not true. So my only solution out of the ones they gave me is negative 4. All right, last problem. Determine if negative 2.4, negative 4.8, and negative 7.2 are solutions to the inequality y over 12 plus plus negative 0.8 greater than negative 1.3. All right, so then if I replace y with negative 2.4 plus negative 0.8 greater than negative 1.3. Okay, so this means divide. I'm dividing 12 into 2.4. Right, so I'm going to bring up my decimal and we'll go 2 times. So this is 0.2 and it's negative because I have a negative divided by a positive. So negative 0.2 plus negative 0.8 greater than negative 1.3. Right, so 0.2, if I add these together, since they're both negative, 0.2 is 0.8 gives me 1.0. Still negative, so negative 1.0 is that greater than negative 1.3. All right, well, negatives are often kind of tricky if it helps on a number line. Look at where it would be. So negative 1.3 is here. Where's negative 1.0? Is it closer to 0 or further? It's actually going to get closer. So as the numbers approach 0, their values seem to lessen even though they're getting bigger as you move to the right. So this is greater than negative 1.3. So then this is a true statement. Negative 2.4 is a solution. All right, let's look at negative 4.8. Over 12 plus negative 0.8 greater than negative 1.3. Okay, so I'm going to just start with dividing. 4.8 divided by 12. All right, so if I do 12 into 4.8, it'll go into 48 4 times, but I bring up the decimal, so this is negative 0.4, oops, plus negative 0.8. So if I add these up, negative 0.4, so 0.4 and 0.8. Since they're both negative, I'm adding. That's 12, 1.2, and it stays negative, so negative 1.2. Is that greater than negative 1.3? All right, so where is negative 1.2? Okay, is it over here or is it over here? Well, it's right here, negative 1.2. So again, okay, it's to the right, so that means it's going to be bigger than negative 1.3. So then this is true also. Right? This is true also. So negative 4.8 is also a solution. All right, look at the last one, negative 7.2 divided by 12 plus negative 0.8 greater than negative 1.3. Right, so again, I'm going to start by dividing 12 into 7.2. Bring up your decimal, we'll go 6 times. Negative divided by a positive is negative. So I have negative 0.6 plus negative 0.8. I'm going to add those up because they're both negative. So 0.6 and 0.8, 14, 1.4. It's going to stay negative because these are both negative, negative 1.4, greater than negative 1.3. Right, so is this true? Is negative 1.4 greater than negative 1.3? Well, where is negative 1.4? It's over here. So is it greater than this one? If it's to the left of it, it can't be greater, okay? Because the numbers, as you go to the left, are smaller. This is not true, so this is not a solution. So comparing negative numbers, okay, sometimes it's confusing. So it's kind of the opposite of what we think. If it were positive, right, 14, if you get rid of the decimal just for a minute, is 14 greater than 13? Yes. But with negatives, the reverse is true, okay? 14 is not, or negative 1.4 is not greater than negative 1.3. Again, inequalities are going to be pretty tough if you don't know what these mean. So make sure you understand that this one right here, the first one, is less than. Starts little, gets big. That's how I remember less than. And that this one is greater than. Starts big. And then when it has a line underneath it, it's less than or equal to. When it has the line under this one, it's greater than or equal to. Okay? All right. I will see you in class.